start on the command line. This is a very mathematical poem. We're going to have an A-B rhyme scheme. And note that if you just say A-B, but you want a 4-line poem, the algorithm knows to just, I want A-B, A-B. It'll repeat the pattern throughout. My syllables, I want 3, 5, 8, and 11 because I'm feeling Fibonacci. And I want it to be about rotten holidays because it's that time of the year. So this gets parsed into a data structure, a list of rule sets, one for each line. So the first line, program, here I've listed them as A, B. The program will actually look in the database and find a random end sound, some sound that already exists in the database, and assign it to A. So it's going to look for a line with an A rhyme sound, 3 syllables, and the keyword rotten. So this is where we start from. This is a simplified view of the constructors I use. I implemented this in object-oriented Perl. And each of these rule objects in the rule sets knows how to convert itself into SQL. So the SQL that then gets generated is how the sentences are actually picked. You can see that it starts out very, very simply. We're going to select a sentence, well, all the sentences from our list of lines where we have a particular end rhyme sound, a particular number of syllables, and the sentence has to contain that word. Start out very, very easily. Note that the objects converting themselves to SQL are just producing these basic logical assertions that can be parenthesized and then appended to a series of AND statements. That's all the SQL calls end up being. But it doesn't always work that way. Our SQL doesn't always stay that simple because we don't find what we want. So here's a trace of some SQL that's getting weakened. So let's go through this. We started out looking for particular end rhyme sound. So we break this apart. AE is a vowel sound. The number represents a stress. So it's either 0, 1, or 2. There's a different stress in the vowel sound. And then whatever consonant sounds came after that to the end, all the way to the end of the word. So you'll see that the program is having a hard time with it. It's not finding what it wants as a rhyme sound with this stress, so it'll drop to a different stress. Still can't find it with the other constraint. It'll drop to the third stress. And it really gets flustered and says, all right, trivial rule, it just becomes a true value. It'll just take any old rhyme sound at that point. Similarly, the number of syllables in case 2. We start out wanting 10, but we'll drop into this between 9 and 11, between 8 and 12, and so on, until finally it finds what it wants. It finds a sentence predictably with a number of syllables between 7 and 13. So we're going to move into some examples. This is the first poem, the first haiku that my algorithm produced. This is using the Borges corpus, which is very small. You'll notice that you get repetition, and this is something that I purposely left in because it can often be useful. So in this, I thought this was a wonderfully nice occurrence of repetition, as this is a book about something, or a poem about something cyclical. So it works. You'll notice that there's stray punctuation. This is something my algorithm doesn't take into account. It doesn't really care about mismatched parentheses and brackets. It just ignores them for now. So you'll also note that this isn't an ideal haiku. We discussed them as 4 syllables. Haikus are traditionally 3 lines with 5 syllables, 7 syllables, and 5 syllables. But it's actually really hard to do syllable counting. There's no precise algorithmic way to do it that I discovered. And then I'm using a method that is accurate that uses phoneme counting, but it occasionally has to fall back to about an 80% accurate method. So you'll end up with these kind of loose haikus, but they're still neat. You'll notice a lot of the output of the program ends up being funny. And this is a result of, I'm using a database with 440,000 lines that have no thematic consistency. They're just books I grabbed off Project Gutenberg. And so you end up with stuff like this. Jack picked it up. Sounds complicated. The woods are on fire. He doesn't know what just happened, but the woods are now on fire, and he's freaking out. And that's, again, these sentences, I don't have a corpus with any kind of consistency, with any kind of thematic consistency.
Just read both of them because the screen is so low that we can't see them.
Oh, okay. The second one is, Alexander said, "Boys, whose animal is this? A crazy man's doings." So these sentences are random. The corpus isn't targeted in any way. It's just 440,000 sentences just stuffed in together. But you'll still get poignancy. So here are 2 that I think carry some nice meaning to them. Harry's son nodded. 3 columns and 2 arches. Glory may not last. I like this one. I can envision a family out at the Acropolis, and it's the 1950s, and Harry's son is standing there looking out over these ruined buildings, and he's counting the arches because he's only 6 or 7, and he has this Ozymandian realization that Gloria is not going to last, that even the Acropolis is going to fade. And that's great. And the fact that Gloria may not last is in caps is just kind of an added bonus. That's actually a book title. Project Gutenberg left all cap titles all throughout my corpora, which is fine. The second one, the spring was coming. What sort of looking men? You will share in their work. It feels biblical almost. And again, random. I mean, none of this was intentional. Move on to some couplets. These are just pairs of rhyming lines. You'd use these to end some longer pieces. I'll read through these. Will I? Answered the small youth. He guessed a great deal of the truth. But the affair was growing serious. Her prim phrasing changed to earnestness. No, answered Lenora bluntly. Can you blame us if we did go crazy? Again, I actually, because some of these were so hauntingly consistent in terms of semantics, I mean, I didn't have to search very long to find these. And I was convinced that my random sentence picking was all way off, and then I was getting sentences that were right next to each other. So I actually searched through my million-line, 440-sentence text file and discovered that these lines are just thousands and thousands of lines apart. We're talking, I mean, distant, very distant. But because the corpus is so huge, and this is getting back to my hypothesis, the corpus is so huge, we have a very favorable signal-to-noise ratio. The diversity in the number of sentences works very much to our advantage, and we end up with this kind of accidental, topical, and semantic consistency. What's next? I'm not doing scansion. Scansion is line metering, so stress counting. It's actually really hard. I've only found one implementation of algorithmic scansion written by a poet, actually, who just knew enough about computer science to be able to program what he knew about scansion into an algorithm. Unfortunately, he wrote it in Python, not Perl, so I couldn't immediately incorporate it in my project, so that's kind of in the future. More sophisticated corpus processing, you'll probably remember the straight parentheses. There's a lot of stuff like that. My apostrophe handling isn't great, and just things get kind of messy a little bit. I left it out because it doesn't affect the meaning, exactly of the work, but I do want to have it be a more cleaner presentation in the end. More sophisticated corpus acquisition. I don't want to be up late writing scripts that scrape Project Gutenberg or Wikipedia, which is a nightmare. I never try to do that. And so I want a way more sophisticated way to acquire new corpora, because it's really going to pave the way for this program being useful. If I don't have to write a new scraper script for every single thing I want to use. Finally, parallel programming. If you're an astute pupil of contemporary computer science, you'll note that data structure with the rule sets is an embarrassingly parallel structure. You can compute each line of the poem independently because no line of the poem has any relation whatsoever to the lines before or after it, which means that the second you've parsed the user input into a list of rule sets, your program could fork n number of times for each line of the poem and produce each line in parallel. I thought that was really neat. The 440,000 line sentence database, I could actually produce poems pretty quickly out of. So I didn't have an immediate need to resort to parallel programming, but I certainly want to thread this or do something in the future. Some potential applications. Something that a friend suggested at a poetry group event was, well, take this and do like vanilla chocolate twists of different authors. I mean, can you imagine taking Charles Baudelaire and then mixing him with Robert Frost and have self-inhibiting poems about filth and decay? And that sounds really neat. And you can get at some really great contrast and juxtaposition between different authors, Whitman and Plath, and really ruin your day. Next, you can do news sources. Again, to get at kind of hidden juxtapositions. Take the Drudge Report and the Huffington Post. Take New York Times and all of Fox News' online content and really jar them, make some jarring comparisons and smash these things together. A kind of more serious one, status updates from different social strata. So one idea that I had is sociologists might want to say, okay, well, here's some person located in socioeconomic class X. Let's look at their friend network on Facebook. Let's take every status update ever written by them and their friends since they joined Facebook and make that one corpus. And then let's take someone else from a very different location, different part of the world, and do the same thing. What kind of poems get produced by different people's social networks? What does the literacy look like? And it becomes kind of this imprecise but creative way to do data mining. And it kind of puts the fun back into spying on people because you're producing these works